Hi, my name is Gina Denny, and this is my design project for electrical circuits. For my project, I will be designing a color-changing LED light. My design will consist of 3 LED lights, a red, a green, and a blue light. Using 3 different switches, the lights can be turned on and off to create a total of 7 different colors. This circuit is intended to be placed in a decorative piece that light can shine through. It will also include a capacitor that can be used as a backup battery. Here are a few examples of what this circuit could be used for. The lights can be placed inside of any sort of decorative piece that light is able to shine through, like the paper lanterns or the cloud lantern on the right, and could hang from the ceiling or sit on top of a desk or shelf. For my circuit diagram, I tried to mimic what would be available to me if I had a circuit kit to do this project myself. My design utilizes 3 AA batteries, making a voltage source with a total of 4.5 volts. I chose this amount because it was the smallest number of batteries I could have with the LEDs at their maximum brightness. There's also a 5 ohm resistor that is needed for the capacitor, 3 single-pole double-throw switches that change between either a resistor and LED in series or a single resistor, and a 100 millifarad capacitor. The resistors that are unlabeled on my diagram will be solved for in my calculations. Moving on to the calculations, we will first solve for the unknown resistances. Each LED has a specific value for the maximum current that can flow through it and the voltage drop across the LED at the maximum current value. If these values are exceeded, the LEDs would likely burn out. Using the appropriate values for the resistance would ensure we reach these values for maximum brightness without ruining the LED. We can solve for these values using KCL, KVL, and Ohm's law. We will start off with all the LEDs switched on. We can also ignore the capacitor for these calculations because the most current will flow through the LEDs when the capacitor is fully charged and no current is running through it. Here's a list of the values for the forward voltages and currents for each LED. I found these values using the website for Jameco Electronics. We will first apply KCL to find the current running through the 5 ohm resistor, labeled I1. Doing this, we have that I1 is going in and the currents through the LEDs going out. We input the given currents through the LEDs and find that I1 equals 90 milliamps. We can also calculate the voltage drop across the resistor using Ohm's law, so V1 equals 0.45 volts. We apply KVL to find the values for the resistors. The diagram on the right maps out each loop that is used to find each resistance. Through this, we find that the resistance with the blue LED to be 8.3 ohms, the resistance with the green LED to be 48.3 ohms, and the resistance with the red LED to be 61.6 ohms. I want to note that because these values are not the nicest of numbers, if I were to actually build this circuit, I would use potentiometers to use these exact values. Now we have to solve for the remaining resistors. In my design, the resistances when the LEDs are shut off are supposed to ensure a current equal to that of the current through the corresponding LED and resistors so that when 1 or 2 lights are off, the current running through the lights that are on does not increase or decrease and therefore remains at its maximum brightness. Since the current through each is 30 milliamps, all 3 resistors are the same value. They can be found using KVL loops. This value is found to be 135 ohms. We are also able to solve for the maximum voltage that the capacitor can hold. We can do this by looking at the node voltages labeled to the right. We can see that VC equals VA and that VB equals 4.5 volts. We use Ohm's law and the node voltages to find VA and therefore find that VC equals 4.05 volts. To verify my calculations, I used MATLAB Simulink. I did one model as though the LEDs were on and another model as though the LEDs were off. I did this because I was having trouble with using switches and decided that I would be more successful creating 2 different models instead. With the switches on, I measured the different currents going through each resistor. As you can see, the measured values are very close to the current values in my calculations, meaning that the resistor values were accurate. The same goes for the resistors with the lights off, showing that the currents are the same as in my calculations and the resistor values therefore accurate. Here's a diagram of my final design, including the calculated resistances. In the end, and I'm left with an effective circuit that could be easily built at home.